In this video, we're going to analyze graphs of linear functions from Unit 9b. Let's consider the graph to the right. In words, describe the function on the graph. So according to the function, the rain depth, that's the y-axis here, increases by about 4 inches every 3 hours. So they went up 4 and right 3. To find, this is called the slope. They made a triangle here that goes through 2 points here, and they found that there's an increase of 4 in y when there's an increase of 3 in x, or that as the slope is 4 over 3, and this is 4 inches in 3 hours, and they interpreted that slope in words here. The rate of change, we just found it, is 4 over 3 inches per hour. And briefly discuss the conditions under which a linear function is a realistic model for the given situation. It is a good model if the rate of the rainfall remains constant over time. You see that linear functions have a constant rate of change. The slope does not change. All right, let's look at our next problem here. Consider the graph to the right. In words, describe the function shown on the graph. So now this is distance from home in miles on the y-axis, and this is time in hours on the x-axis. So according to the function, distance from home decreases by 800 miles every 9 hours. We don't have another good point to look at other than the two intercepts, that this was 0, 800, and this was 9, 0. So that was C, sorry. And then the rate of change is going to be exactly negative 800 over 9, but we want to round this to a decimal because it says to the 10th place. So that's going to be negative 88.9. And then this is going to be miles per hour for our units. Miles per hour. And it is a good model if the speed is constant for 9 hours. Right? And consider the graph to the right that relates a person's height to their shoe size. Let's go ahead and in words describe the function shown in the graph. According to this function, shoe size increases by 4 every 50 inches. So here's 4, sorry, right here. 4, so we start off with a 1 here, and then that's going to be the 0.55. And if we look at 100 up here, that's going to be 109, and so on. So it has a slope of 50 denominator and 4 in the numerator is going to give us 8 over 100, or 0.08. this was A, and this is going to be size per inch. This is size, and this is in inches, so size per inch. And this model is a rough approximation at best. We know that the shoe size people vary greatly with their height, but there is the general trend that as people get taller, their feet get bigger and their shoe size should increase. Also, be careful with such a model as this, that there's only a reasonable height for people. They can only get but so tall, and their shoe sizes will usually only get but so big. All right, so both your domain and range should be kind of limited here in this type of function. That's it for this video. We'll come back next time and keep talking about Unit 9b. See you for the next video.